Okay, hyperbolic functions and integrals of hyperbolic functions. If you want to have a little bit of understanding about what hyperbolic functions are, I'm not going to take the time to read this, but go ahead and put it on pause if you'd like to read it, or actually go to Wikipedia and read it yourself and get more information about it. Most of you high school students that aren't going into engineering may not be that interested, but those of you that may consider engineering, this would be interesting. All right, so kind of the nuts and bolts. On your note sheet that you're going to have, it gives you derivatives of hyperbolic functions. Hyperbolic trig functions are notated. What should stand out are these H's that you see here, right? That indicates this is a hyperbolic. And the derivatives are almost just like regular trig functions. The derivative of sine h of x is cosine h of x. But notice, the derivative of cosine h of x is not negative sine, it's positive sine. The three main trig functions, sine, cosine, tangent, all of their derivatives are positive. But the reciprocals, cosecant, secant, and cotangent, each of theirs is negative. Now, cosecant and cotangent, for a regular trig function, its derivative is negative. But the secant one, its derivative is now negative. Okay, notice the derivatives, other than the positive negative, are all the same with the addition of the h's. And notice what I did here. Excuse me, I'll put this on pause for. Okay, so the reason I'm showing you, let me get this out of the way. So the integral of cosine, the hyperbolic cosine, is the original normal function, f of x. So when you take the integral of this derivative, you are just working backwards. So the integral of sine h is not negative cosine, it is positive cosine h. The derivative of secant h squared is tangent h. The derivative of negative secant h cotangent h x dx, the integral, is cosecant. It's hard to read, cosecant h. Anyway, you get the idea. Just remember that these three hyperbolic functions, the derivatives are all positive and the integrals are all positive. But for the inverse functions of the main trig functions, the derivatives are all negative. And then when you take the derivative of those negative functions, the integrals go back to being positive. All right, so let's do a couple of examples. So if you're given f of x is sine h of x, the derivative, I can do this again, is cosine h of x. And then if you're to find the integral of cosine h of x, well, it's sine h of x plus c, since I made it an indefinite integral. But what happens when you have an argument in there with the x? So it's sine h of 2x. Well, the derivative would be cosine 2x, but then multiply by the derivative of 2x. So you get 2 cosine 2x. Well, now what if we want to integrate 2 cosine h 2x? So we go ahead and write it up as an integral, and it's indefinite, so there's not an a to b. And we could bring this 2 to the outside there if we wanted, and then integrate this. I think that's probably what I did down here. Yep. And I remembered to put the h right there. Good. All right, so then when you take the integral, remember when you're taking the integral of, so the integral of cosine, I'll just call this ax. Well, the integral of that is going to be the reciprocal 1 over a cosine ax, or cosine ax divided by a, something like that. So the integral of cosine is sine of cosine h, sine h, the 2x and the 2x stays. And then when you integrate, you do the reciprocal of this argument. Now we're still multiplying it by this 2 on the outside, but look at 2 times 1/2. Those cancel, and what that leaves is sine h 2x. That's what we started with. So that's the big takeaway. When there is an argument and you're taking the integral, whatever this a is, when you integrate, you divide by that a. All right, I hope that helps. That's it for this one.